in teaching mathematics, and that is, it's a government-funded organisation, and the idea is that its aim is to support improvements in maths teaching in England from preschool, primary, so age 4, all the way up to age 18. My personal level of real expertise in maths education is right up at the school-university interface. But because of the job that I have as director of this organisation, I've also learned a very large amount about primary maths teaching in the past 3 years. So I believe that most of you are secondary teachers, is that right? How many of you have any primary maths expertise? Yeah? Yeah, okay, yeah. Elementary, I beg your pardon, I need to, yeah. If anything I say you're not sure about, just ask. One of the things that I've learned from having to look very hard at primary maths teaching is that teaching elementary school mathematics is not elementary at all. It's actually very difficult, and it's very sophisticated, and I think that sometimes secondary teachers don't quite realise that. So again, that's something else that I'll touch on a bit in my presentation. Okay, so one of the things that we have in 2010 we had a new government, and it's like a change of politics, I suppose. We had a government of particular persuasion for a long time, for 13 years, and then it changed. And what politicians always want to do with education in England is make a splash. They'll always claim that everything is going wrong because of what the previous administration did, and want to change it. And one of the things that the government did was want to introduce a new maths curriculum. There was an idea that I'm sure this is probably have you heard in all of your countries as well, that having a workforce that's well educated in mathematics brings lots of economic benefit. And so that's a great motivation for wanting to improve maths education. One of the problems I think with sometimes with governments getting involved in that sort of thing is that they are very impatient. They think that huge cultures can be changed very quickly, and part of my job is to try to limit their expectations a little bit. But we are, I think, moving in the right direction. Okay, so we've got a new national curriculum. So in England we have the core subjects have a curriculum which is defined by government. And the idea is that this curriculum is what everyone will learn. And there are certain assessment points in the curriculum. So there's a point at the end of what's called Key Stage 2. So that's at age 10, 11, and that's between elementary school and secondary school. And there are national tests at that point. And then there are, at the end of what is year 11 here, so when children are age 15 or 16, they do examinations called General Certificates in Secondary Education, GCSE. And our cohort is around 650,000. So each year 650,000 young people do this GCSE maths exam. And actually, it's a very high stakes for them and for their schools. If they don't pass that examination, they'll have to resit it over the next 2 years, and it's very, very difficult to, in the employment market, they're severely disadvantaged if they haven't at least passed maths at that level. So they can go on and do maths to a higher level after that, and some of them do, but that's a really key point for them. And what the government has done is made GCSE mathematics harder. And they've done that because they've looked at it internationally, they've compared our curriculum with other countries, and they've said, actually, we're behind. Our curriculum, we don't expect as much of our young people mathematically as other countries do. And so and it says here introduced for first teaching from September 2015. What that means is that the first examinations in the new GCSE will be next summer, 2017. I've got 2 children, a son and a daughter. My daughter is 17, she did the old GCSE. My son is 15, he'll do the new harder one. He's not very happy about that, but that's life. Okay. Something else that's happened is that we used to have a system where within local regions, the local councils, so I suppose controlled regionally, would have facilities for supporting the schools in their area, and they might employ somebody who is a maths education expert who would work with teachers locally, but they'd be employed by government. And that has been effectively stopped. So that type of local support, the idea of the new government was that improvement in education should come from within schools. We have some schools that perform very well, some perform less well. What we want is to try and make it so that the system can work within itself to make itself better. And so it's a school-to-school improvement model rather than something that's top-down. it remains to be seen how well that will work, but we're trying our best to make it work, and I think that there are things about that that I think are very good. And one of those things is that sometimes people from the outside trying to sort of preach to teachers and tell them what to do, if you like, have no real understanding of their day-to-day work. And actually a kind of a school-based bottom-up model of support, perhaps that can be more effective. But you know, that's still new. Okay, so one of the things that we've done to try to help make this new system work is that the NCTM, we've set up, and we've got government funding to do this, we've set up a network of maths hubs around the country. And what that means is that there are 35 schools around the country that have been identified as being really excellent in maths teaching, and the idea is that they can help coordinate school-led improvement in schools around them. And ultimately, the hub is more than the lead school, it's that other very high-performing schools in their area, in their region, will form a network, and everyone can sort of work together to share good practice and to really understand what problems are on the ground and try to address them. And it's been going for about 2 years, and it's starting, I think, to work and to have an impact. People are always very resistant to change, but I think, you know, now it's becoming more embedded, it's beginning to work. Okay, and the key idea about these maths hubs is this bit about school-led improvement in maths education, and the idea that it should be evidence-based. So, you know, maths education research, information from around the world, we should be trying to learn from other people and sharing ideas and trying to get this right in a more scientific way, I guess, rather than just saying, well, that seems like a good idea, we'll try it out. I'm not completely sure that we're managing that properly, because, and the reason for that goes back to what I was saying earlier about how impatient politicians are to do things. You can't have really solid evidence-based things happening and have things being done very quickly, so we have to compromise over that. Okay, and the idea is that the maths hubs are developing, and a key role of the NCTM, the National Centre, is to work with the maths hubs and develop their expertise in being able to support other schools and understand, I suppose, properly how to train other teachers, work with other teachers effectively, work with other schools effectively. Because again, one of the things that I suppose it's obvious really, but the fact that you, as a school, are very successful and get very good results from your pupils doesn't mean that you're necessarily going to be very good at helping other schools to do that. And so what we're trying to do is to help them to develop those skills. Okay, so that's the maths hubs. Right, Shanghai. I guess that you probably all know that Shanghai, from the PISA tests in 2012, Shanghai is at the top in maths by quite a big margin. And our politicians were not very, you know, they're worried about that. I think they view almost as a kind of a national affront that we're so far down the table in terms of performance in PISA. And so one of the things that they want to do is to see, you know, can we learn from what they do in Shanghai? And I'll just show you this very quickly. Hopefully it will open. Is it coding? Right, you can't see it very well, but the important point is that the United Kingdom is the one that's shaded down there, and if you look at our mathematics score, then we're on 494, and Shanghai's on 613. I guess you can probably all see your countries in there somewhere as well. But
we're all looking for it.
yeah. But yeah. So it's a Czech Republic. Yeah.
And Italy.
Oh yes, Italy's there. Yeah. I'll scroll down a bit to find it.
No, we don't want to know.
Yeah. But anyway,
which place?
Okay, so you get the idea. There are all kinds of. I mean, I guess that you probably know that PISA is not nearly as simple as politicians think it is. But nonetheless, it's the sort of thing they take notice of, and it leads them into sometimes taking very, very rapid action about things. Well, one of the things that happened as a result of this is that I was, you know, at the time there was a minister in the Department of Education, her name was Elizabeth Truss. She's since been promoted, She's now doing something different, but at the time she was very, very interested in maths, and that was actually very helpful. A very helpful thing about her as a minister was that her father is a professional mathematician, so she kind of understands maths, which was very helpful for me at the time. And you know, why is Shanghai performing so well? Is it all about culture? How can we find out? What can we learn? And as a result of this, I, with a kind of a delegation from the government, excuse the mistake there, went out to have a look at maths teaching in Shanghai. And I literally had a meeting, you know, about 4 weeks before I was on a plane. They were so keen to deal with this and do it quickly. So what I would say about this is that I had all kinds of kind of preconceptions and prejudices about what I'd see in China, which I'm actually quite ashamed of now. I felt that, first of all, the people in Shanghai could not have been more welcoming. They were fantastic, and obviously very, very proud that they're doing so well in maths. One of the things that I was worried about was that we have, and I don't know whether these stereotypes are shared internationally. I kind of had a view of children sitting in rows in silence, doing as they were told. No interaction really going on, just like the children as sponges, if you like, absorbing what came from the front and being so intimidated by the thought of getting anything wrong that it was almost sort of drummed into them, this education. And I thought, well, before I went, I thought, if I see that, how am I going to deal with that with the politicians back at home? Because, you know, we can't do that. We wouldn't want to. But actually, what I saw in Shanghai was what I would be recognised, all of you would recognise, as absolutely fantastic maths teaching. It was a complete revelation to me. And one of the really important things is that they emphasise so strongly proper understanding and connectivity within mathematics, from an elementary level up to, I saw teaching up to age 15. I mean, after that, I think that the education changes after age 15. It's very different. But up to age 15, the teaching that I saw was absolutely fantastic. Really strong emphasis on connectivity of ideas, really strong emphasis on, even from small children, really sort of properly understanding things. You know, getting the answer right isn't enough. Can you explain why that works? Can you explain that precisely? And I'll give you quite a lot more detail about this, and I'll show you a couple of Chinese lessons as well, and we can talk through those. But I think the main feeling that I had at first was relief. I thought, you know, if I've got to try to, you know, do something to improve maths education in England based on seeing what I've seen in Shanghai, I can certainly do that, because actually I'm not going to do anything different to what I've been doing before. But what I've got now is a brilliant evidence that actually if you do teach maths properly in this way, it really does work. Other things that is worth saying though is that Shanghai maths teachers and maths teachers across, certainly the urban areas of China, they, at primary level, so elementary school, they've had 3 years of specialist undergraduate training in teaching elementary mathematics. They really do know their stuff. In England, our primary teachers, often their highest level of maths qualification is the qualification they took at age 16, and many of them, well, they passed, but not much more than that. And there's therefore a huge difference in terms of the mathematical expertise of the teachers that at elementary school level in Shanghai compared with our primary teachers. At secondary school level here in England, our teachers are better qualified, but they're still not as well qualified as the teachers in Shanghai. And the status of those teachers is very high. Something else is that they only have contact time of about 2 hours a day. So they're actually teaching children for a couple of hours a day. When they're not teaching children, they're planning, they're seeing children individually. I'll tell you more about that later. But they're really, one thing that they do very well is that within each school, and the schools can be enormous, but within each school, the mathematics department, the members of the maths department will work together, they'll exchange ideas on how lessons have gone that day, they'll compare notes and work together. They're all working from a common textbook, which I'll talk more about as well. And they are analysing forensically, you know, really in detail, how their teaching works. each week they'll have that. There'll be at least once each week. They'll have a proper, almost like a debriefing about how the lessons have gone and how they can make them better next time. And for teachers in England, our teachers are basically just trying to get through the day because they've got a lesson and then another lesson and then another lesson, and they're just trying to keep their heads above water. They haven't got that amount of time to be able to really analyse things so closely. So again, that's something that I'd like us to try to emulate here in England, but it needs sort of changes in the structure of how we organise our school day and that kind of thing. But I'll talk more about that in a bit. I mean, in your country, I guess you've got a whole range of different things going on, but you know, it was notable to see that. So I went to 3 cities in Shanghai, in China: Shanghai, Wuhan, and Beijing. Wuhan is I'd never heard of Wuhan. Its population is only about 13 million, so it's a relatively small Chinese city. But it's kind of let me get this right. It's west of Shanghai, and then obviously Beijing. Okay, so yeah, the big thing for me was I was very impressed with the teaching. I could see how it was working. I could see that if we could teach like that in England, that would certainly improve things. But I could also see lots of barriers to it. Another thing that's worth saying about Chinese children, in the class, they are very, very well engaged. And part of the reason they're engaged is not just because they're well disposed towards learning or they're frightened of being naughty or anything like that. It's partly because the teaching is so engaging. But lessons tend to be 35 or 40 minutes long. When the lesson ends, they go absolutely crazy. They are as boisterous, if not more so, than children in England. And I was actually really encouraged to see that. I wasn't expecting that. Again, it just shows a kind of unfair stereotype that we can pick up about things. So their children, I spoke to lots of their children. Many of them were able to speak English well enough to talk to me about their maths, which was astonishing. But they were just like children in England. Okay, so I've got some features. So all maths taught by specialists, including primary, forensic approach. I've said this. Strong professional collaboration. I mentioned that. Textbooks is a really important thing that they have there, and I'll show you a bit of video in a minute about talking about textbooks as well, because they don't use the idea that you say get your textbooks out and turn to exercise 4 on page 37, and then I don't want to hear from you again for half an hour. That is not how they use textbooks in Shanghai at all, and I'll talk more about that. But the textbooks, they are very, again, they're produced centrally, and the feedback from teachers goes into improving those textbooks. So they're developing all the time. Short lessons, 30 to 40 minutes. Whole class teaching, a very important thing that again, in England, at primary, at elementary school level particularly, I don't know whether this happens in your countries, but one of the things that happens at primary schools here, so this is children aged between, say, 4 and 11, is that somehow their primary teacher, who remember is not a maths specialist, forms an opinion about how good they are at maths, and then will sit them with children that they think are of a similar ability in maths, and will possibly teach them different stuff depending on how good they think they are. And there might be in one classroom, in one maths lesson, there might be 4 different groups, all doing slightly different things, or sometimes very different things, and we've got to stop doing that. I mean, essentially what happens is that if you are, it seems to me that if you are considered to be not very good at maths by your teacher when you are 4 or 5, remember a teacher who is not a maths specialist, then the educational experience in maths that you have is dictated by that, and that can affect the outcome at the end of your schooling. And in fact, there's lots of evidence to say it does affect the outcome at the end of your schooling. So, whole class teaching, this idea here is that the whole class is exposed to the same curriculum in the same way. And that, one of the reasons that we've done this what's called differentiation, having different tables, if you like, for different children, is an attempt to be kind. To say, if you find it difficult, then we'll try and make it a bit easier for you. Absolutely the wrong thing to do. And I'll talk more about that as we go on. Yeah.
Can I ask, what's the typical class size?
Beg your pardon, right. Typical class size, big. Smallest class I saw was 40. I saw classes with 60 children.
One teacher?
One teacher. Yeah.
With a microphone.
60 is the biggest, 40 the smallest.
40 the smallest.
Yeah.
So lessons are made with microphone?
No.
No?
No, no.
And the students are quiet?
The students are completely engaged in the maths. You've got to see it to believe it, really. It's, yeah.
Sorry, can I just follow on from that? Do they have the same approach to special needs and assistance,
Right.
assistance in the classroom?
Okay. In terms of assistance in the classroom, I didn't see any assistance in the classroom. In terms of special needs, I don't know how they deal with their special needs children. I haven't had exposure to that. But I do know that that the vast majority, by which I mean sort of 80% plus of the children, are being taught in this way. So that there are I had unanswered questions from this, and that's one of them. Yeah.
Okay. 30, 40 minutes, elementary class or a high school class?
Both.
The same?
Both. Yeah. Yeah. But 30 or 40 minutes of really intense engagement and concentration, followed by them going completely wild when the bell goes. Sorry. Okay. This thing about, again, teacher-led, so there's lots of the teacher at the front, but lots of interaction going on. So it's not sort of copy down what I write on the board. There's lots of very careful questioning, and the children they stand up to answer questions, and they're again encouraged to use very clear mathematical language. If they get something wrong, then the teacher will just say, "No, you're wrong." But there's no kind of shame associated with that. The idea is that then, has anyone else got an idea, and that will be discussed. So even though sometimes I certainly have done this when I'm teaching, you kind of feel apologetic towards a child that's got something wrong in a public way, but they don't view it like that. They say, this is all part. We're all learning this maths together. The fact that you've got that wrong is there's no shame associated with that. But we'll just move on. Which I think is an important idea. Another thing that they do is that do you know what a visualizer is? It's like they have a lot of whiteboard projector screens like this, and they will have a visualizer. They'll have a child bring their work out to the front, and they use a visualizer to project a child's work up on the whiteboard, and then they might discuss that. And the child's work might be wrong or it might be right, but they'll talk about individual children's work in that way. Children also are encouraged to go up to the front and write on the board. So they're very engaged in the lesson. Okay, so pupils going up the front to share solutions. Now, a really important thing about mastery, and I'll talk in more detail about mastery in a moment, but the idea is that if in maths, because of the way that maths works, because of the way it's connected, if you misunderstand the key idea, then if that isn't fixed, then that misunderstanding will go with you.
What you were saying yesterday.
Yeah. So what happens is that they, in the way that they teach, and I'll show you this in a lesson that I show you, that they try to identify very quickly, if they can in class, they'll identify if children are misunderstanding something, and will try to fix it there and then. But they also will set quite a lot of homework, but not long tasks, and not huge amounts of marking, just things that will identify whether the children have got the key ideas. If they haven't, they'll intervene very quickly, and they'll draw those, sometimes individually, sometimes a group of children, but not in class time, separately outside. And there's time in the day to enable this to happen. Because what they want to make sure is that the children are secure, and you might say they have mastered to sufficient depth, if you like, the maths that they need to progress in the future. So the way that they will stretch and challenge children and differentiate, you could argue they differentiate in this way, is they'll ask very deep questions about simple mathematical ideas. And some children can get those right and some children can't do that. But the important thing is that they're testing that all the children have got sufficiently deep knowledge to be able to make progress. And the structure of their teaching, and I'll show you in a lesson, the structure of their teaching helps them to do that. Okay, so yeah, low class context I talked about, large classes. I did see one of 40, I'll put at least 45 there, that's not quite true. No differentiation by ability, so that they don't actually recognise this idea that some children are more able than others in mathematics. The idea is that they're all children learning mathematics, and if some do better than others, then their general sort of cultural belief is that that's because they've worked harder. Yeah? And the idea is that, and that's really this. Sadler said that you've already done some stuff about mindset, and the idea of one of the things certainly in our culture in England is that we can individuals think that they are either good at maths or bad at maths, and if you think you're not good at maths, then what that means is that even subconsciously, even if you're a conscientious person, if you think you're not good at maths, then you will not be motivated to study it because why? I'm never going to be really good at it, so I won't worry. There are also dangers if you think you are good, if people keep saying you are good at maths, because it can make you not want to take any risks. I won't try that hard stuff in case I find out something I don't want to about myself, in case I'm wrong, I'm not as clever as I thought. But in China, they don't think about mindset. It's just their culture is that if you want to get better at something, you work harder at it. So they have a growth mindset almost embedded in their culture, and we need to try to do that here, I think. So they've got a real sort of positive can-do attitude to learning maths. I think that obviously there are individual differences between the potential that we have to learn mathematics and how far we can go with mathematics. But I think that for children doing maths up to age 16, the proportion of children that can succeed in maths to that level is much, much higher than actually I think many of our teachers believe. Part of where this mindset comes from is actually projected from teachers, isn't it? And from parents as well, and all those things. It's in our culture and hard to change. But it's very noticeable. They just don't have that. I tried to have a conversation with them about this, and they weren't really sure what I was talking about. It's that level of cultural difference. Okay, so this is a secondary classroom. Bit of interaction going on, but they're all very smart. They wear their scarves and stuff, so they're very smart in that way. And teacher at the board, but there's always interaction going on. So that's just a photograph taken in Shanghai. Right, this is very interesting. What we've got here is that this is a class going on, but this is a room at the back of the class with like a one-way mirror, so that you can observe the teaching going on.
Wow.
Yeah, and that is common. Yeah, and the idea is that teachers watch each other teaching absolutely as routine. There's no threat involved in that. It's not judgmental. It's about let's watch how it's going and let's work together to make it better. It's all very positive.
Every classroom have that?
Not every classroom, no, but many classrooms. Many classrooms.
Did this happen in our planet?
Yeah. So it's that culture they have of working, maths teachers working together to do what they do better, and learning, observing each other, learning from that.
I think you mentioned something, but how does the status of a teacher compare to here or Europe?
Oh, I think the status of a teacher is high in Shanghai. I haven't looked into the economics of it. I don't think that they're super well paid. But I think that they are, if you are a teacher of mathematics, you are somebody, certainly. And deserving of respect. And there's aspiration to become a maths teacher, which is not, it's rare actually in England for young people to aspire to become maths teachers. The ones that do are normally absolutely committed. So it's an ambition for many young Chinese people to become teachers.
Sorry, again, in England it's not an ambition to be a math teacher.
To become a maths teacher, it's an ambition for some people, but not for many. I don't think. I think that a young person wouldn't proudly declare, when I go out into the world of work, I want to be a maths teacher. It wouldn't be viewed in such a positive way. And that's something that we need to change actually. Okay, so the result of all this is that they learn maths deeply. I think that's the important thing, that we often have a kind of develop a sort of if the children are getting things right and there's lots of ticks in their books, then everything's fine. And actually that's not true. They need to be understanding how these ideas are interconnected, making those links, because one of the things that happens, I think, is that there's a style of teaching that almost that can be successful at a superficial level, that almost kind of misrepresents what maths is, because you kind of learn recipes for doing different types of maths question, and you're not really learning mathematics in a way that means that you can use and apply it. And the other problem with that is that the further up the education system you go, the more maths you have to learn. If you're trying to remember it all in a way that isn't making connections, it just becomes almost impossible to do unless you've got an extraordinary memory. You know, I like to think that the reason I got into maths when I was at school is that I'm naturally lazy, and I realised that actually if you understood how these things work, you kind of work it out. But I actually think that many people don't understand that maths is something you can work out. I think it's something that you know or you don't know. And that's, that's something we need to fix. And again, so the way that the style of teaching in Shanghai is this idea of deep learning in maths. Okay, so one of the worrying things is that I think I said that I went to Shanghai in February 2014, and the only maths educator that went was me, and I wasn't a primary specialist. I just watched what I saw at primary, and I thought this looks really good to me, and I liked what I saw at secondary. But when we came back, you know, the idea was, well, you've been out there, you liked what you saw. Can you organise a teacher exchange for September this year? And actually, we did that. We organised a primary teacher exchange to start with. I was absolutely terrified about all the things that might go wrong with that. Thankfully, it actually went very well. And I'll talk a little bit. I'm going to not spend too much time on this, but this is an English language joke. So if any of you, I showed this slide in Germany, and one of the audience got it. I was very impressed. But the idea is that okay. So you're gasping with fear at the dinosaur, yeah. And thesaurus is like a book that you look up, like words that have similar meanings or whatever.
Synonyms.
Synonyms, that's right, yeah. So you know, anyway, sorry.
Oh, it's good, it's good.
It's the only joke you're going to get. Right, so we believe we could improve maths teaching in England by learning from the Shanghai teachers. You know, in spite of all of the things that are so different, actually just the approach in the classroom, the approach to the kind of underlying idea that you teach maths as an interconnected subject, and that really will work, and that you have this more growth mindset approach, idea that you should be doing whole class teaching and enabling all children to access the maths. Those ideas are transferable. So yeah, our teachers were concerned about the new national curriculum, and they really were concerned about it. And I think that actually that's partly sort of time lessons things, but also I think that generally speaking, our teachers are coming to terms with the idea actually we can do this, or you know, or at least perhaps we can do this, whereas before they really didn't think so. So we felt that this Shanghai teaching could support the implementation of the new curriculum, make it successful, and so we went out to Shanghai. So we did it through the maths hubs. So each hub selected a primary lead school. So they found a primary school in their area, and obviously what we want is schools that are very confident about teaching maths. And so we took 2 teachers from each of these schools, 35 schools, 2 teachers from each school, spread across the whole of England. We took them out to Shanghai for about a week to sort of watch what was happening there, and our teachers did not teach in Shanghai. They watched the Shanghai teachers teaching, and they developed relationships with those teachers. And one of the things that we also did with the primary schools is that primary schools are very much, so elementary schools, are very much run by their head teacher. So, you know, if the head teacher has got to be on board for anything to really happen at primary school. So we sent out a primary head teacher and a primary teacher confident with mathematics. And these schools were, it says each hub selected, but they essentially, schools applied. They said, we'd like to do this, and they were selected from that. So they were volunteers, if you like. And so they went for a week, they observed teaching, and to my immense relief, they were hugely impressed with the primary maths teaching as well. Because that was my worry. My worry was that, you know, I'm not a primary specialist, but this is actually, at primary level, this is being done on the basis of what I've said about it. So that's quite sobering. But fortunately, they thought, well, actually, this is great. And the idea is that they visited Shanghai schools, and the schools they went to, they were tied particularly to a given school. And the idea was that teachers from that school would come back to England and teach in England. And I'll talk about that in a moment. But the idea is that they'd already got to know people. One of the things that I was very keen on, in fact I was very insistent about in organising this, was to say that we must have Chinese teachers, Shanghai teachers who speak good English, because this just will not work if we can't do that. And well, that didn't prove to be a huge problem. They were able to find Chinese teachers who wanted to come to England, who were good maths teachers in China, who were prepared to come here and teach in our schools for about 10 days and teach in English and translate all of their lessons and everything into English. And I was absolutely awestruck by what they did. It's humbling, actually, how the kind of level of commitment. I thought, imagine that I had to go to China to teach maths in China. Well, absolutely no chance whatsoever. I mean, obviously, everyone in Shanghai learns English, but nonetheless, it's a humbling thing. Okay, so yeah, they spoke they taught between 2 and 3 weeks, and we had 2 waves going. We had some come in November, so our teachers went out in September, and from half of those schools, teachers came over from Shanghai in November, and they taught for 2 or 3 weeks, and then the second wave of Chinese teachers came over in February, and lessons were widely observed. So not only were these Chinese teachers coming to England to teach maths to children that they've never met before in a foreign language, but also we were having other teachers come and stand in their classrooms and watch them do it. So I take my hat off to them. They were fantastic. But literally, approaching 1,000 teachers watched the Chinese teachers teach while they were here. Okay, and in the autumn, we ran a similar exchange concentrating on lower secondary school. So that's autumn of 2015. So we did it again. Last term it happened then as well. So 2 years running we had these exchanges. We did it with secondary. We chose to do it with lower secondary school because the Chinese secondary teachers have the children that they are teaching things like times tables, number bonds, so really sort of arithmetic things. Chinese children at age 11 are completely fluent with those things, whereas many of our children aren't. And further up the school, the differences get wider and wider. And we felt that the place where we can probably learn more from them is if they're teaching children at 11 or 12. And well, I'll show you a couple of video clips. So first of all, let me just show you. This is a very short clip. It's a head of maths. Why have I got no volume? I have volume just now.
Our children, the experience has just been fantastic. Going in September and seeing how it was over in Shanghai, it was incredibly impressive, and I wasn't sure how that would translate back into England because our children are different, the culture's different, and their background knowledge is different too. But it's been an eye-opener that they can come here and use their ways, and the children have really developed. And all my staff have watched them, so we've had a lot of visitors as well. It's been brilliant.
Can you pick out 1 or 2 things which they do, which are maybe different, about which you were sort of pleased that your children responded well?
Yeah, I mean, the main thing is their design of lessons. We plan lessons, but they design them, and the intricacies of every question that they ask leads somewhere, goes somewhere, and is thought of. And that is just incredible to watch. The other thing really is the beauty of the maths. Their solutions, the way they work through things is incredibly elegant. And we've looked at them and said, oh wow, of course you'd say that because it follows on to that. And that progression that they get from all of their topics is really just amazing to watch. I've been teaching a very long time, and I feel incompetent next to them, in that way. They just develop the language incredibly well and the understanding, and they take everybody with them. So some don't understand at the start of the lesson, and more come on board. By the end of the lesson, they're there, and just to watch that progression within the lessons is something special.
Okay, so that's a lady who's the head of a maths department in a school in Herefordshire, I think. And she's a really very experienced teacher, and her school is a very good school. And the one of the things that she talked about there was how the sort of preparation. She made a distinction between designing lessons and planning them. Design is a really detailed procedure to get these lessons right. And one of the things that strikes me about this is that, as I said before, in China, the teachers are working together all the time. They're analysing what they've done and constantly improving things. And they're doing it within schools and also doing it between schools across Shanghai. So the lady said that she felt incompetent next to them, but actually she's designing lessons as an individual, or possibly in her little department, but they've got the benefit of all of those teachers working together on them and all of the experience they have from watching each other teach and all of those things. So actually, one of the reasons that their lessons are so great and the teachers are so successful in delivering them is because of the work that's gone into producing lessons like that. And if we can get that culture here in England amongst our maths departments and between our maths departments, and the maths hubs can be part of that, that's what we want to try to do. Because the way they were teaching maths, there was nothing in it that we thought, this is something we would never have thought of. It's just that they are performing it at a really, really high level. They're doing what we would aspire to do. We aspire to that, but they actually do it. And they're doing it partly through this kind of collective effort. And I think that's something that we want to try to learn from. There's a collective effort that goes into the textbooks, collective effort that goes into the planning of the lessons, them observing each other, all of that is all part of this. They're almost like it's their mission, to teach maths better. And they really think in that way. Right. Okay, hold on. I'm going to show you a bit from another video. And these videos, all of these videos, you can download them from the NCTM website. But hold on, let me just pause it. Right. So these are three of my colleagues from the National Centre. So they went out with the teachers, and the idea is that we sort of run the exchange when the teachers come back, when the Chinese teachers come back, and we want to sort of make sure that we can learn as much as possible from the exchange. So these are three colleagues of mine, and this is them just sort of having a chat about their experience of going out to Shanghai. I'm going to the whole video is only about 10 minutes long, or 11 minutes, but I'm going to just show you a couple of short bits from it. Okay.
One step, and then the links around it, and then moving it on a little bit, and then moving it on a little bit, and that is given to them as a core. What they do around the edges of that is what makes it different, or makes it interesting to walk from one school to another school. Is a slightly different approach you get, but and then moving it on a little bit, and that is given to them as a core. What they do around the edges, the teachers have a very consistent set of approaches to teaching key topics. One step, and then the links around it, and then moving it on a little bit, and then moving it on a little bit, and that is given to them as a core. What they do around the edges of that is what makes it different, or makes it interesting to walk from one school to another school. Is a slightly different approaches you get, but there's a great deal of consistency in an approach to teaching the mathematics there. Yeah.
One of the things that we were really struck by is this curious mix of lessons seem to be very simple, and yet they seem to be very complex. There was one simple idea that was in quite short lessons, often much shorter lessons than we were teaching in England, 35, 40-minute lessons. One simple idea was gone over and over and over. But the complexity of the examples that were chosen to help students understand that simple idea was very powerful, and it's something that a lot of English teachers that we talked to, we went over there with, that's what they're going to try. One simple point in a lesson, but complex, deep examples to exemplify that.
Stop it there. Hold on. And I want to move up to.
We took 68 English teachers.
And children would do some work in a workbook, and they're often, they would write in the work.
Right, start here.
Textbooks are very influential in the way teachers plan lessons and so on. There's a thing that we have possibly, the notion of a textbook lesson, which is the instructions from the teacher. I open your textbook at a certain page and do this. We didn't say any of that. And children would do some work in a workbook, and they're often, they would write in the workbook. So the examples and their solutions to them would go in the same book. But that, because it was short activities and then discussion. There weren't long periods of time working through textbook pages, but the textbook was a common foundation, so that often we went from lesson to lesson and we saw this teacher is using exactly the same really good examples that the teacher we saw yesterday used in that lesson. So they've got a confidence that they're sitting on a very solid foundation of really good materials that everybody uses.
The textbooks are developed from their curriculum standards and match the sequencing of mathematical topics in the curriculum standards. So the teacher doesn't have to think too hard about what do I teach now, what do I teach next, because the curriculum standards tell you that, the textbooks tell you that they match perfectly. And they're used Shanghai-wide, so again you have this enormous level of consistency through primary and lower secondary.
But what I did see too was in some of the planning sessions, teachers going, yeah, actually, we'll use those ones, but some children may need a bit of support with that. And also, I think that last example is a bit naff, and perhaps we'll just put in a different one that makes children think down this route because that's what's coming next. So they weren't using it blind. They were looking at it, thinking about it, critiquing it. Sometimes they put the examples up on the whiteboard rather than get the children to work in the book because they just needed 5 questions, so they just put on the board and talked about it. So they were using them flexibly. It wasn't that we would have to do it exactly the same way.
So there's a very nice element that we're seeing about the materials were very good for the students and helping them learn, but the materials were very good for the teachers. They're almost a professional development tool. We're helping teachers see, you know, what good examples look like, and they were tweaking them in creative ways, but they had something to interrogate. Why has the textbook author chosen that particular sequence of activities? Oh, I see. And because, maybe this is where we get into the other thing that was very striking that we saw, because they spent a lot of time as teachers talking about that together, you know, collaboratively planning lessons using the shared materials. Conversations happen a lot between teachers about why this material has been chosen in this way and why it helps us to teach really well.
Yeah, they were very strong on it.
So again, this idea about textbooks, and I don't know, in our primary schools, it's very, very rare indeed for teachers to use textbooks. And yet they're not very confident with maths. I mean, that's crazy, isn't it? They're all developing their own teaching materials for maths, something that they're not necessarily very confident about, and trying to deliver teaching and learning from those. Wouldn't it be just much more sensible if we could develop some really good textbooks and have those not as something that you just give the children to work from to keep them quiet, but something that kind of underpins the way that we're teaching maths. You know, sequencing things properly, having, as my colleague Pete was saying, you know, having really great examples that all teachers can use because they've been developed, you know, over time by lots of teachers working together, and they really work well. So I think that's you know, the textbook thing is something again which is a bit of a revolution in this country to use textbooks in that way. But my prediction is that in 5 years' time, in primary schools we were using textbooks very widely for teaching maths. In secondary schools, there is some textbook use in secondary schools here, and some schools don't use them very much, but again I think they'll be used much more in secondary schools as well, on the basis that, you know, if they're very good, if they're very sort of well constructed, well researched, as the ones from Shanghai are, they really are a way of improving teaching and learning for everybody, and not having teachers trying to sort of reinvent the wheel everywhere. But you know, actually they've got something really solid to build from. But you've got to have something good. One of the problems that we have is that we have those textbooks are produced by the Shanghai Municipal Education Authority, and similar things happen around China. Here we have publishers that are trying to sell a product. So one of the problems, I think, one of the things that the National Centre for Excellence in Teaching Maths is trying to do is to make schools and teachers more discerning customers. You know, you need to be able to understand what makes a good book, and you know, publishers they want to shift books off the shelf, don't they? You need, if you want to get really good quality products in that way, you need to have customers who are able to assess properly the quality of what they're buying. And at the moment we don't have that here, and we need to develop that. I think that it's not in our culture to have a centrally designed textbook and say, here everybody use this. I cannot imagine us doing that. Personally, that's what I'd want to do, but I can't imagine us doing that here. Yeah.
Did you find that there's competition between schools to like league tables or high performing, low performing?
Oh, I think they are very proud of how well they do. Yes. So they they do have competition between schools, but it's not. I think it's constructive competition. I think the idea is that there's a kind of understanding that that by competing with each other, we're raising everybody's game. We have competition between schools here in England, and sometimes it's one of the things that happens sometimes is that it results in the less successful schools becoming even less successful, and the more successful schools becoming even more successful, because parents will influence where their children go and all that kind of thing, because there's notionally some kind of choice in this country about which school you send your children to, and it means the parents with the sharpest elbows, if you like, the ones who are most forceful about the future of their children, are desperate to get them into the best possible school, and that actually it does the opposite of what education should do. Education should close social division and equalise opportunity, but if competition works in the wrong way, it does the opposite of that, and we have a bit of that here at the moment, I fear. Okay, so what I'm going to do now, I'm going to show you a lesson, and this is I watched this lesson take place. It's given to a Year 8 class, so 12-year-old children, and in Devon. I actually live in the West Country, so for once I stayed down in my part of the world and went to see some lessons in this school. Okay, so this is a lesson about division of fractions. It doesn't actually go as far as division of fractions. One of the things that we've talked about is the idea of these lessons being really focused on one key point. One key idea is dealt with very deeply. And this lesson is actually about, well, I won't spoil it. So this is the teacher's PowerPoint. Okay, so the teacher was doing exactly what I'm doing and showing something. They've already done multiplication of fractions. So the start of the lesson is, you can all do this, so do this. And obviously what we want to see out of here is that the answers to all of these things will be 1. But the really surprising thing is this, isn't it?
Yes.
I mean, that is very formal. Yeah, strict proper notation with 12-year-old children. But they do that all the time. Here you've seen here there's a pattern going on. We're going to get the answer 1 out of each of these. Okay, let's write that. Let's write what we're doing in a general way. Okay, and that's it with 12-year-olds. So fill in the blanks. So here the idea is that you're trying to put the number in here that will make the product equal to 1. So they're getting this idea, and and the general one on the end. Now there'd be lots of interaction going on. So the teacher will be talking about this. Then they put this up, and the children here will be perfectly at liberty to talk to the children around them, and be interactive about it. But it's all it's very focused and like any football fans out here? Any football fans?
Yeah.
Tiki-taka, like Barcelona, backwards and forwards all the time. With the teacher, yeah? Okay. So, and the teacher has this, and she'll say, what's going to come up next, and all of those things. So just a fairly standard thing. But that exercise is looking at it both ways around, and this general thing on the end. Okay? So, please observe the table. What conclusion can you get? So the idea is that if you multiply a fraction by that fraction inverted, you're always going to get 1 as the answer. And that there's a kind of discussion that goes on in the room about that. Have you sort of spotted this point? Okay, so if the numerator and denominator, now, not if the top and the bottom, if the numerator and denominator. The teacher insists on those words being used. And actually, we have this view, we don't want to frighten the children with these technical terms. That's just wrong. Give them the real thing. Don't apologise for it. Okay. So if the numerator and denominator of 2 fractions are inverted, then their product is 1. And here's this as a general statement. And again, look at this. Even to the detail of P and Q cannot equal 0. And a little discussion about that in the class.
And I'm sure that came about from experience.
Yeah.
Right?
Okay, so look at this. This is like a university thing, isn't it? Definition. Yeah. If parts of a number A and B is 1, English isn't quite right there. But if parts of number A and B is 1, then A is the reciprocal of B. And
sorry, 8 years. 8 years old.
No. Grade A. 12 years old. 12 years old. Sorry. I thought I said 12, but perhaps I didn't. I apologise if I misled you about that. So yeah.
Sorry.
No. It's probably my fault. So I apologise. Okay. So. Okay. Now the thing about this is that this was a lesson that was being delivered to English children who have been through our system. So they've not seen anything like this before at all. But actually, they really engaged with it. It was I mean, obviously, one of the things that we put Chinese teachers in nice schools, and we made it clear to the schools made it clear to the children that these people are our guests. They've come a very long way. They're teaching in a foreign language. Don't be mean to them. But actually, it wasn't just that the children were there, kind of putting up with it and doing as they were told. They were absolutely engaging in this. Lots and lots of interaction going on between the teacher and the students. And that's with this lesson, the teacher that I saw here had been working with these children for about, she probably taught them 4 or 5 times, 4 or 5 lessons by this lesson. But it was as if they had a long-term teacher-student relationship. It was amazing. Okay. Right, then here's an exercise. And the idea of this exercise, very simple, draw a line to connect the reciprocal from left to right. Now, the children are given this to do, and they're doing it. The teacher's going around, just looking over their shoulder. Have they all got this? Because it's a really quick diagnostic thing. If they can't do this, they haven't got it. So I better reinforce that again. Yeah, so there's lots of things like this where they've got little tasks to do, which breaks up the dialogue in the class and gets the children thinking, but also it enables the teacher to identify whether they've understood what they need to understand. So, yeah. Okay. Right, then we've got this thing here, another exercise. Find the reciprocal of the following fractions and conclude the solution. What conclude the solution means? Well, I'll show you. What conclude the solution means is... Hold on. Right, hold on. Have I got the end of this? Just a minute. No, I beg your pardon, right. What she means by conclude the solution is say that 4 over 11 times 11 over 4 equals 1. So actually write that down. So that's what conclude the solution means. It's not she explained that to the children as well. But bear in mind that she's her first language is Mandarin. That's not bad or anything. Yeah. But this idea of conclude the solution is important. It's not just write down the reciprocal, but actually write down 4 over 11 times 11 over 4 equals 1. Really embed that point. Okay, then we've got these integers here. Now look at this.
Yeah.
Look at that one. That's interesting, isn't it? What about that?
Yeah.
Yeah. It's really forcing the issue, making sure that you're not fudging around things. You're actually tackling these ideas head on. And then with the mixed fractions, the idea they've got to turn them into rational fractions and just turn them over at that point. And we've got reverse Newman denominator, change it to A over 1 first, change mixed number to an improper fraction. Right, then there's a bit of a game. So say a number and pick a friend to say the reciprocal of the number. And again, teacher going around, if anyone can't do this, I want to know that now. So, and again, this idea that the lessons are conducted in stern silence, absolutely not. Really engaging. Okay, and then we had this true or false thing. So if the product of a number A and B is 1, then A is the reciprocal of B. Is that true or false? So, okay, right, that one's true. If C is the reciprocal of D, and the product of C and D is 1.
True.
Okay, that's true. The reciprocal of 2 3/5 is 2 5/3. Okay, so anticipating the kind of errors that students will make, bringing that out in the open, discussing it with them all. Each number has a reciprocal. Well, not 0. Okay, so let's be clear about that. No number has a reciprocal which is exactly itself. Well, yes, it does, it's 1. But it's making those points. The key point about reciprocal is being embedded again and again in this interaction.
But it's not just saying what it is, it's actually making them think.
Exactly right. Exactly right.
That's awesome.
Okay, so conclusion. Reciprocal of x does not equal 0 is 1 over x. Reciprocal of p over q, p is not equal to 0, q is not equal to 0, is q over p. Great. Okay. 0 does not have reciprocal because no real number multiplied by 0 produces 1. The product of any number with 0 is 0. Okay? But, you know, these points. And the teacher might ask to say this, you know, say these things out loud. Yeah, sometimes. And I was amazed they were perfectly happy to do it. It was just part of what they were doing. In positive numbers, only one number has a reciprocal, which is exactly itself. 1. Let's see, in positive numbers. Okay, very, very strict. Okay, now, this whole thing, this lesson was leading. The next lesson was going to be about dividing fractions. So, they did this reciprocals lesson, they'd done multiplying fractions before, and the next lesson was going to be about dividing fractions, and I didn't see it. But I did look up in the textbook about how they do dividing fractions. And so this here is me just saying this is what they do. So in the textbook they have something like, oh no, beg your pardon, no, we're still in the, sorry, take that back. We're still in the lesson at the moment, reciprocal and division, and we're saying that if that is true, then that is true, and so is that. Now that's something that they do with children from when they're very small. Now if I know that one number times another is a third number, so I can't write anything, can I? If I know that A times B equals C, then I also know that C divided by A equals B, and C divided by B equals A. And that is talked about from when children are 5, 6, 7 years old. They're talking about those relationships all the time. So they understand that when they've got one thing, they've actually got more information than that. So this is a completely natural thing for them to write. Okay? If that's true, I have both of these facts as well. So we're still in the lesson at the moment. So exercise 7 is change the multiplication to division. Okay, so what they mean with these, again, is to do that. So if I've got that multiplication, then I've also got these two division facts. And again there, and again here in a general form. Okay, and so the children are doing that, and they've done multiplication fractions. So now they're saying, having done multiplication fractions, I can now write down some division things as well, because I know about how multiplication and division work. I know deeply how they work. And that's been reinforced right from primary school. So they also, when they're teaching, they always in primary teach addition and subtraction together, and multiplication and division together. So A plus B equals C, C minus B equals A, C minus A equals B. That's just done and reinforced all the time, similarly with multiplication and division. It makes these things much easier later on. Okay, look at this. Quotient. Yeah? That